On this edition of the Embedded Insiders, Brandon and Rich ponder whether RISC-V is taking too long to become a mainstream technology, or if it will even ever be one. Despite being open source, will RISC-V be all that it has so far been made out to be? Later, the Insiders are joined by Mark Himelstein, the newly appointed CTO of the RISC-V Foundation. The three discuss the architectural future of RISC-V and how he plans to drive the technology deeper into the hearts and minds of engineers. Later, John Labrosse is back with more Things That Annoy a Veteran Software Engineer, where he explains why he hates when APIs return meaningless error codes such as 0 for success and 1 or -1 for failure.
Welcome to another edition of the Embedded Insiders. I'm Brandon Lewis here with Rich Nass, who, what did you just say? You let the barn door open before the cows hit the tree?
No, before the lightning hit the tree. It's been raining here like every afternoon for about almost 2 weeks now. And it's not just rain. I'm in Florida. And it's not just rain, it's vicious lightning. And I was never really afraid of the lightning before. And the other night, the lightning hit the tree in front of my house and scared the you-know-what out of me. I had buried some wire for my lighting outside right in front of the tree. And it made that whole thing blow up. And looked like a bomb went off like right behind the tree and made a big hole where the wire was. But it was, anyway, what led to that is that I ordered some surge protectors, but a little too late. But I guess better late than never.
Well, you're a techie guy. Why didn't you just build your own surge protectors?
Because they were $10 on Amazon.
You can't beat $10.
No, I can't. I mean, I can't source the products and build it myself for less than that.
For sure. Well, just for your future reference, I think the barn door reference has to do with horses and not cows running into trees.
Whatever. I want to talk about RISC-V. And is it taking forever to become a mainstream technology? Or am I jaded and it just takes a long time for things to sink in and before all the tools and the infrastructure gets built?
Or will it ever be a mainstream technology?
Oh, you just pissed off some people.
It obviously takes a while for a technology like that to get integrated into the ecosystem. But the big claim to fame when RISC-V came into being was the important thing about the instruction set is that it's not important. RISC-V sort of stopped looking at developments and advancements that had happened in instruction set architecture and design pretty much after the early 2000s, and just went with some traditional RISC-based instructions. And that's fine in some cases, but in others, that's not necessarily advantageous. So for example, one of the things about the RISC-V instruction set that is not so conducive to modern development is the fact that in order to index an array, you need 3 instructions in RISC-V. So that means you've got a whole bunch of branches, you've got bigger code sizes. It should be simpler in theory, but there are trade-offs. Maybe it just won't be all that it was cracked up to be.
But the biggest promise was that it was open source. And that really hasn't seemed to resonate all that much as far as I could tell. Like I know a while ago, Microsemi, now Microchip, offered their IP out to the community so people could build their own chips. And if people are doing that, I'm not aware of it. Are you aware of anybody who's taken advantage of that offer?
Well, I think there are some people building chips, but then again, how many people were building chips before RISC-V? I mean, just think about it. If you had to guess at a number, how many companies out there were designing and manufacturing chips, let's say? 100? A few hundred?
Yeah, I'd go with the bigger number there, at least a few hundred.
Okay. So there are a few hundred companies out there, but you're also talking about a whole lot of validation and verification. I mean, the investment required to build a commercially stable, commercial ready piece of IP that eventually gets integrated into a larger SoC, or build an SoC yourself. I mean, you're talking millions of dollars, millions and millions. It's not just the guys who decided that they were going to start some app in their garage and they just spent their weekends for 6 months coding. It's a completely different ballgame. So in that respect, open source is truly that type of open source we talk about, where free means free speech, not free beer, right?
Definitely. But is it taking the amount of time that we would have expected, or is it shorter, longer? I would think that from what I heard from, fortunately, some of the smaller companies who are, for better or worse, betting their companies on this technology, it's not moving as quickly as they would have expected. And certainly they would have liked, because I don't think there's anybody making any money from RISC-V at this point. I can't think of anybody.
Well, sci-fi maybe, but the other point of that too is, let's think of the addressable markets, data center, maybe some AI training and modeling. And then you have the consumer space where you've got laptops and cell phones, et cetera. And then you've got embedded devices. Well, the really nice meaty chunk of revenues are probably going to come from that middle sector there of consumer type devices, laptops, cell phones, and then also, of course, networking devices if you move up the food chain a little bit and then into the data center. But all of those applications are already pretty well dominated by existing architectures. x86, Intel, and ARM are pretty much have a monopoly in a lot of those areas. It's not like you just decide one day, okay, well, our data center infrastructure is going to switch from Intel to this new RISC-V thing, or even Intel to ARM. I mean, we've seen ARM trying to make a push into the data center for years, I mean, going on decades now, and that hasn't happened just because Intel was so entrenched. So is there a space for RISC-V in those areas? If there is, it's going to be a long time before it makes headway, which leaves those embedded devices, and maybe there is an opportunity there. If you have smart sensors that need, some sort of logic, why not just drop a RISC-V core in there and call it a day? But then what's the economic opportunity in those types of systems? It's not the same as the other applications we're talking about.
You left out an interesting person here in this discussion, the guy who says he has 25,000 customers being Microchip, yet he has invested in both ARM and RISC-V.
Speaking of other architectures, AVR, they were like a one-stop shop. But it doesn't really hurt to integrate those into your portfolio. But do you think that...
Well, hold on. Do you know how many millions of dollars? I mean, what does hurt mean to you? Hundreds of millions of dollars.
What I was getting to was actually that maybe some of those peripheral type architectures weren't the core of the acquisitions. What does Microsemi do besides RISC-V that Microchip did not have before?
Yeah, they had a big mill portfolio and rad hard stuff that Microchip did not have any of.
And FPGAs. And other than that, with Atmel had that ARM presence. So AVR was, of course, there and part of that offering from Atmel, but it gave them an opportunity to get into the ARM space. So maybe those are nice throw-ins, RISC-V and AVR, and hey, if these things take off, great.
Okay. There's been some movement over at the RISC-V Foundation. I understand there's a new CTO there. Did you hear that news?
I did hear that news. Maybe he can give us a little bit of insight into what's coming down the pike for the open source ISA.
Now, the insiders are joined by Mark Himelstein, CTO of the RISC-V Foundation.
Do you have any big architectural changes in mind for RISC-V?
First of all, RISC-V has this incredible advantage of being at this side of history. We got to look at MIPS and Spark and Power and Alpha and HPPA and learn from them. In ARM and Intel, it's really a great position to be in. We have an incredibly intelligent group of people who are designing this thing. And on top of that, we also have the great examples of Linux and Hadoop in the open source world. So this is the first really open source chip of this magnitude being done from scratch in open source. For that, it's just incredible. And so when I look at RISC-V, and I know those other architectures very well, I just look at simple, elegant, and the thing that we didn't really have early then is this flexibility of going all the way from embedded IoT kind of space all the way up to supercomputers. And these guys have done a brilliant job in doing that. If you ask what I'm going to bring to the architecture, I have a fairly clear software perspective to it. I ran Solaris for 5 years. I've done architecture work and development work, done organizational work. And so I'm going to bring a holistic view to the whole ecosystem and help us take the changes, take the innovations, and make them successful for everybody throughout the stuff that goes from the bottom all the way to applications.
So is that your politically correct way of saying you won't be making the same mistakes that the other guys made?
There's always opportunity to find new mistakes. Even if we don't make the mistakes they made, I'm sure we'll make our share. The good thing about our stuff is that we do have versioning, and so we do have the opportunity to come back. Obviously, you want to do it in a compatible way so that in the future applications continue to work, but new applications that want to take advantage of new stuff, just like other chips have done in history, can go ahead and do that.
One of the things you mentioned earlier is the wide breadth of applications that RISC-V can be applied to. Right now, where do you see the most uptake being?
You got to understand too that the runway for different segments of the industry are longer or shorter. So if you want to go ahead and create something that's HPC or finance enterprise or oil and gas, those kind of things have a big ecosystem around them, and people are working on them now, but the runway is a little bit longer. The guys who are doing IoT, embedded, targeted kind of stuff, they control the horizontal and the vertical, right? So they can go ahead and control their environment. I think you're going to see deployments happen more quickly in the embedded IoT network edge or specific cloud computing kind of environments where they have a specific set of things as opposed to being a general purpose computer. And those general purpose things will take a little bit longer, but they're being worked on as we speak.
Looking at opportunities to really drive RISC-V further and further into the development ecosystem. It takes a while when a new technology is introduced, especially at this level with an ISA and then corresponding chips afterwards, to get really driven into some of those use cases like you just mentioned. What's your strategy for helping accelerate that type of adoption, if you think it's even possible in some of those market segments?
Oh, I definitely think it's possible. Look, this is some of it's just basic blocking and tackling. We have to have all the pieces there. Again, I have a bigger purview over architecture than some of the people who may be working on specifically bit manipulation instructions or something like that. So I have a broader view, and so I can help bring sensibility that helps us provide a sort of a complete ecosystem around this that enables those markets to be successful. And because I've had this experience all the way from applications, I've worked on finance applications, search applications, database applications. So I worked on a broad set of those things as well as the stuff underneath. I can help bridge that gap and really go into these industries and figure out what it's going to take for those guys to be successful, because that's changing every day, and make sure that that stuff's available so everybody can get off the ground, get their product out quickly. I mean, in the end, the thing that's going to help RISC-V the most is deployed, proliferated, real product.
In the past, some of the other architectures who have tried to advance these open ISA, open core type philosophies, one of the places that they've really fallen short is in a lack of a software environment. Obviously, you mentioned some background with Linux, and also RISC-V seems to be at least a couple steps ahead in that regard to some of the other initiatives in the past. That being said, where is the biggest gap for technologists today? Is there still a need for a lot more software and tools, or do you think more architectures and extensions at that level are required?
I think it's a really good question. First, I want to acknowledge all the work that everybody's done, because all the standard things are basically there. We have a number of OS ports already, Yocto building, things like SEL4, Zephyr. We have Debian and Ubuntu, and we have Red Hat involved. So all the major players, and we in no way are going to to hold it to there. There's a lot more. So we already have that stuff in place. But again, they brought me in specifically to look at things. So the first thing is software, absolutely. And in a lot of places, it's not necessarily whether they have work in that area, but whether it's complete or enough. So we're looking at those things from platforms perspective, from standards perspective, from life cycles, applications, infrastructure. All those pieces are required in order for this to be successful. Next, there's a set of attributes that are horizontals across all technologies that have to be really in place. This is one of the places that's way different than the 1980s. If you just take the security stuff alone, which is one of the biggest attributes, everybody selects what their environment is, because depending on what their environment, nothing's free, security's not free. But we have a really, really experienced group working on that, and they're going to make it possible for everybody to have it be a secure and perform as well in the security environments as possible. But there's also RAS, there's performance. These are things that go across everything. And then finally, and this is a little bit backwards, it's a little cart dragging the horse, but I think that happens naturally as organizations evolve. But we're moving more towards taking a look at the industries, automotive, finance, oil and gas, telecom, etc., high performance computing. We're looking at those and really trying to take a complete look at those and what they need to succeed in making sure that stuff is there.
RISC-V uses a lot of the basic concepts that were developed through the 1980s. And one of the benefits that enabled was that you could start to freeze portions of the ISA to enable this scalability and longevity. But on the other hand, there have been advancements that allow people to code more efficiently, let's say on ARMv8. x86 continues to add extensions to its ISA. So do you think that that's going to be an issue moving forward? I know that some people I've talked to say, man, when I'm coding on RISC-V, I've got so many extra branches that I wouldn't have in an ARM context. So Mark, can you respond to that?
I will tell you that, again, we have the benefit of history. There's a lot of goodness about having fixed size instructions, load store kind of instruction set that we know of. MIPS, Spark, Power, PA, Alpha, they all really went down that line, and you compare what they have to do versus what CISC instruction sets have to do. And it's really quite striking about how you can optimize the logic, how you can do out of order instructions, how you can do a bunch of those things much more flexibly. Is it the only answer? Absolutely not. There's places in the world for CISC and for RISC, and that's been true for the 40 years I've been involved with this. So I think it's an exciting time. It's kind of a renaissance time for software and hardware. I mean, how many databases are out there? How many other innovation pieces are out there? These things have really grown up a lot over the last 15 years, an explosion that we haven't seen before, a variety that we haven't seen before. And RISC-V is poised to help those people do innovative things. Now, do we need to spend more time on the optimizer? Oh, yeah. I mean, other companies have put hundreds of years of time into their optimizers. We've done, the basics. We've gotten off the ground. GCC has some incredible stuff. Some other places, like the other ISVs who do compilers like Green Hills and other places, they all are providing solutions for RISC-V. And we all still need to do more work to take advantage of that stuff. I will tell you, it's come a long way since the 80s. Like, we understand about delay slots and what they impact. We understand about the size of instructions. So we support 16, 32, 48, 64. The 16 very clearly is meant for IoT, right? I mean, it's meant for the bottom. And right now, the basic set of things requires you support the 16-bit instructions. They call it the C extension, the compression extension. It's all about that. But it's not just there. It shows up in other extensions as well. And I pronounce it ZFINX. Other people pronounce it other ways. But floating point instructions working on integer registers. Less precision, but when you have a very small thing, you get to go ahead and still have floating point that has really good properties and still can help the people who need to do embedded solutions and don't want a full floating point unit or quad unit or double unit, right? And so that is about compression. So all these things that affect the cache, that affect the TLBs, that affect the paging systems, and then affect the execution pipeline are all thought about quite significantly. And I think, if you take a look back through history, there's lots of people who've written lots of papers on this, of comparing CISC and RISC. There's significant goodness from the RISC piece, but this has been a raging debate for 40 years. And we believe that we fill a marketplace that understands the value of this and understands what they can do with it and where there are opportunities for other architectures. And, that's okay.
So we've covered a lot of ground here, and you obviously have your work cut out for you. What's item number one on your agenda? Where do you start?
Well, item number one has got to be the relationship with the distros, right? We have to make sure, other architectures in the past have had too many variations, and the distros shut them down until they cleaned it up. We want to get off the ground on the right foot. We have relationships with all the distros, and we want to make sure that it's very clear about what they have to build with, what they have to support for context switches versus using, in particular for the operating systems. That has to be clear, and that has to be clear all the way from the bottom, from the extensions, from the memory order, from the cache configuration, vectors, what are the size of the elements, what are the possible strides, and all these things. All that has to be made clear so that we have clear distros being put out. That's got to be number one. Number two has to be a full gap analysis of all these things, hopefully leading from an agile format. What are the user stories, how people are going to use this in the different industries that I talked about before, and even more industries. And then finally, translating that into filling those gaps with the membership and with the community.
If any of our listeners are interested in finding out more about RISC-V, where to get started, and all of that good stuff, where should they go?
Well, the RISC-V.org website is really good, and it has everything from tutorials you can see to sort of a marketplace of various tools, software, hardware, emulators, etc., that they can do, and we're enhancing that. We're going to have a quick start one where you can do one-button installs and get off the ground quickly. And a number of our members are working on development boards that people will be able to get. They can get some today. We're hoping to get more low-cost boards as time goes on, and we're very excited about that. So again, I think the goal is get people off the ground and get them shipping production product.
Now it's time for Things That Annoy a Veteran Software Engineer with John Labrosse.
One of the things that I hate is when APIs return meaningless error codes such as 0 for success and 1 or -1 for failure, especially for complex APIs. You could use 0 to mean success, but a non-zero value should be used to identify the cause of the error. For example, did I pass an invalid value as an argument to a function? Which argument was at fault? Why was the driver not initialized? Did I run out of buffer space when sending a message to a task? The driver didn't get a response within a timeout, and so on. Also, as soon as you detect an error code down in a subfunction, bubble it up all the way back to the caller and don't change its value on the way so that I could pinpoint the source of the error. So please, 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 write your APIs such that they return meaningful error codes to help during debugging.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.